All right, so we in the ready section of 1.1, it asks us to solve one variable equations. These are just kind of a build on the one and two step equations that we've done before, except sometimes we might see a problem. So this is an example I'm coming up with that looks something like this. It might say 3x plus 12 is going to equal 2x minus 4. All right, and so this is a little bit different from equations that we've seen before because it has a couple of things going on. It has this 3x on the left side of the equation and a 2x on the right side of the equation. So what we want to be able to do is combine our like terms here. So combining the like terms is still the name of the game. And in this case, we have to do it across an equation. So our goals are pretty simple. Our first goal is to get the variable on one side of the equation. One side of the equation. And in general, we prefer to do it on the left side. So when I'm looking at this, if I want to get my x on the left, I have to get rid of it on the right. If I were to get rid of it on the right side of the equation, that means I have to get rid of this 2x. How am I going to get rid of 2x? I'm going to subtract it. I'm going to subtract 2x, and I'm going to subtract 2x. That'll cause that to cancel. 3 minus 2 is 1, and then I just copy everything else down. That 12 is still there, and then this negative 4 is still there. Okay? So I've completed goal 1. I have gotten my x on one side of the equation. Now I just need to solve for x. I have x plus 12 equals negative 4. I just need to isolate x, so that's going to be goal 2. Isolate x. So I'm going to get x by itself. X, unfortunately, is joined by this plus 12, so I want to get rid of plus 12. I'm going to do that by subtracting 12. Subtracting 12. And so x is going to equal a negative 16. Okay. Nothing too crazy, but it does add a little bit of a wrinkle when we have x's on both sides of our equation. But as long as you, one, get the variable on one side of the equation, in this case we did this by subtracting, and then you isolate your x, and thus we've solved for it. Just be mindful of that as we move forward. The next thing I want to talk about is that if you turn the page in your homework and you go to the Go section, so we're still on 1.1, but now we're on the Go, and this is page 6 in the homework, page 6. You'll see that the topic for this one is going to be graphing linear equations. And graphing linear equations is just a fancy way of saying drawing lines. Drawing lines, right? Linear means line, graphing means drawing. You know, we're pretty much just going back to graphing. And when you look at these problems, they're doing it in a couple of ways, and they're not terribly complicated, but I want to make sure that we understand what's going on. So what it'll give us is our xy plane. XY plane. This is our x. This is our y. Sometimes this is called a Cartesian plane. And for the examples here, what it's giving us is it's giving us a couple of points and then asking us to graph a line. So that's going to be our goal here, is we're going to try to graph a line using 2 points. So say, for example, we were given the point 0, 0, and the point 2, 1. Okay? So whenever we're graphing, anytime we're given an ordered pair, because that's what this is called. These are called ordered pairs. Ordered pairs. And what order are they in? They're in alphabetical order. It's x, comma, y. Okay? So when I look at 0, I go on my x, and I go over to 0. 0 is right in the middle. My y is 0. I go up and down, which is also right in the middle. So that's my first point right there. That is 0, 0. The next point is 2, 1. So I go up 1, 2 on my x, And then my y is up 1, so I go up 1 on my y, like this. That's what it's asking me to do. And then to draw a line, I just connect my dots, like so. Put little arrowheads on the end of my line to show that it goes on forever. And voila, I have my line. Now, there is one more thing it will be asking us to do, and that is to understand this concept called slope. Okay? Now, slope is often abbreviated as m. Anytime you see an equation that has m in it, it is a variable like x or y, except anytime we use m, we're talking about something specific. We're talking about slope. And what slope is, well, when you look at this line, you can kind of see it's going up, right? It has a steepness to it. And that slope is better known as, the way that we normally say it is we say rise over run. And you can see I'm writing this as a fraction. Rise over run. And what does that mean? Well, that means the change in y over the change in x. And you see I said the change as I made that little triangle. You know, that little triangle means change. Okay? It's an old Greek symbol called delta. It's a scientific mathematical idea of change. Things are changing. Okay? So when I'm looking at this, I'm looking at my change in my y over my change in my x. Okay? My rise over my run. Okay? So what I want to do to kind of think about it in terms of the image that we just saw is I'm going to use a couple colors. In this case, I'm going to use green for rise, like that. Okay? And that's going to be over my blue for run. And when I look at the graph I made, if I look at this here, I'm going to do my rise, which is my green, my change in y. So I went up 1 on y, so I changed 1. And then I'm going to do my run. I went over 2. I went over 2. So my rise was 1, and my run was 2. Okay? So my rise over run was 1/2. So in this case, I would say that my slope equals 1/2. And that would be my answer. And I did that visually, right? I did that by looking at the problem to figure out what was going on. And we can do this algebraically too. And the way that we do it algebraically is pretty neat, okay? So I still have my change in y over change in x. And so what I'll do instead is I will say my y-coordinate of my second point minus my y-coordinate of my first point divided by my x-coordinate of my second point minus my x-coordinate of my first point. And you might be thinking, Victor, what are you even talking about there? And I'll go ahead and show you real quickly. So in this case, what I'm going to be doing is I'm going to set this up just like this. I'm going to look at my points here. And in this case, I'm going to call this one point 1, and I'm going to call this one point 2. Point 1 is the first one I wrote, point 2 is the second one I wrote. So I'm going to look at the y-coordinate of my second point. Well, the y-coordinate of my second point is right here, 1. And I'm going to subtract the y-coordinate of my first point, and that's there. So 1, minus 0, just like that. Next, I'm going to look at the x-coordinate of my second point, which is 2. And I'm going to subtract the x-coordinate of my first point, which is 0. Easy enough from here. 1 minus 0 is 1. X minus 0 is 2. So that I found, by using algebra instead of looking at it, what my slope is. I want to do just one more example with you guys, just to kind of drive this home to make sure that we totally get this. So I'm just going to take another piece of paper, put it up here. I'm going to leave my slope stuff on the side here so that you can see that, because that's kind of important. I'm going to draw a brand new graph. Okay. I'm going to pick a couple of points. So my point 1 this time, I'm going to say is -2, 4. And my point 2, this time I'm going to say is 3, 1. Okay? So I'm going to graph them first. I'm going to do it visually first. So point 1 is at -2, 4. Remember, this is my x, this is my y, and for my Cartesian plane, my coordinates are x, y. So -2, 4. So I'm going to go back 2, 1, 2 on my x, and then up 4, 1, 2, 3, 4 on my y, right there. For point 2, I'm going to go 3 over my x, 1, 2, 3. And for my y, I'm going to go up 1. It's right there. There's my line. I'm going to connect the dots. La, 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 la. Just like that. Put arrowheads on it so it's clear that it goes on for infinity in both ways. But now, I want to find my slope. And so, I'm going to do it a couple ways. I'm going to do it algebraically first this time. I'm going to use algebra. So this time I'm going to look, I have y2 minus y1, and that's going to be over x2 minus x1, because that's the formula that I need to know. All right, my y2 is right here, so that's 1 minus my y1, which is 4. All right, and so that's going to be all over my x2, which is 3, and that's going to be minus -2, just like that there, okay? So now I need to actually do this. So that's all going to equal, well, 1 minus 4 is -3. 3 minus a -2, well, that's the same as 3 plus 2, and that's going to be 5. So my slope is -3/5. And sure enough, had we done this visually instead, we would see that. You know, if I'm going to do my rise over run, I'm going to do my rise first. I'll see that I don't go up at all, right? From point 1 to point 2, I'm not going up, I'm going down. I'm going down 1, 2, 3. So I'd say this is down 3. And then I'll see that I went over 1, 2, 3, 4, 5. I went over 5. So even this, as my rise over run, shows me that my slope would have been -3/5. Yeah?
So when you do this for homework, do we have to do both visual and then mathematically, or can we choose?
What I would do is I would start your homework doing the way that is most comfortable. You are going to eventually have to know how to do both, but for this first exercise, it's most important to at least understand it visually. Okay? But so make sure when you're doing your homework on the graphs that it's giving you, that you're showing that it's going down 3 over 5 or whatever it happens to be. Just make that very clear on your image, and that will make things a lot easier. All right. Any other questions? Beautiful.